Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at lesson 7.1.3. We are going to build on what we worked on in 7.1.2 when we were first learning about the idea of scaling and multipliers in conjunction with percent types of problems. So let's go ahead and get started. As you have seen many times in this course, there is usually more than one way to solve a problem. When a problem uses portions, that would be fractions, decimals, or percents, there are different ways to write the numbers and different solving strategies to choose from. Today, you will look at the different multipliers that can scale a quantity and see what each of them will help you find. As you work today, consider the questions below. What multiplier should I use, and how can I write an equation? All right, so let's set up our first situation with Hugo. It says Hugo and his family were shopping and purchased a new bed. The bed was a great deal at 60% off of the original cost. The bed originally cost $245. All right, so our first direction is to draw a diagram for this situation, but honestly, I want to actually do that a little bit later. Let's actually answer some of these other questions. It says if Hugo multiplies the original price of the bed by 60%, what will his result be? All right, so we learned in 7.1.2 that if you use the scalar or the scale, the multiplier for 60%, logical value for 60% would be to convert that to 60 hundredths or 6/10. So if we multiply 6/10 times the quantity, that would represent our discount, right? Because it's 60% off. So if we find what 60% of $245, that would be the amount of the discount. Okay. If it said it was 40% off, then 40% would be the discount and 60% would be the price, the actual price. So in this case, it's 60% off, which seems really a lot to be marked off, but hey, they're trying to get rid of that bed, so they want to sell it. So what should Hugo scale what should he multiply the original price by to find the new price? So remember, if you've got 60% is your discount, then the remaining 40% has to be what the new price is going to be. So we would use 0.4 to represent our multiplier. So if we want to solve any problem or this problem here, if we want to find the amount of the discount, we'll choose the 60% or the 0.6 as our multiplier. If we want to find out the sale price or the new price, then we would use 40% because you're going to pay 40% of the original price because it was marked off 60%. Now, as far as figuring out what these numbers are, remember, being able to find 10% of any number is a very important skill to have. You want to be able to find 10% of any number, if you can take half of any number, if you can double any number. I've said that many, many times, but it is so important. If you can do those, you can do a lot of these percent types of problems. So here we know to find 10% of 245, you would just divide it by 10, which would mean you would move the decimal one place to the left. So 10% is $24.50. If we double that, 20% would be $49 because you double 24.50, you get 49. If you double 20%, you get 40%. And that gives you $98. And so right now I can tell you that the sale price is going to be $98 for this. So that means that the discount would have to be $47. So let's go now to the number line, the diagram that we would create for this situation. Here is how we would set up the diagram. Since we're dealing with nice and friendly percents, you can scale this by 10% intervals. And so this would be 0, this would be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100%. And 100% is the original price, the total price of the bed. Then you can find, all right, where is 60%? So 60% is the sixth line over, right? And so what dollar amount corresponds to the 60%? That was your $147. So we can label this as 147. So this part would be the discount, which means that the rest of it This section in here would have to be your sale price. Is there a C in there somewhere? There's a C right there. That's sale price. All right, so we've got everything so far. Now look at D. Work with your team to find the sale price. Okay, so do we have that dollar amount? I think it's found over here, right? If the discount is 147 and the regular price was 245, I guess that must mean that we're paying 40%, which would be the $98. So, wait, how do you know the, oh, I see what we're saying. It says, how do you know the answers from your two methods compare? They are what, maybe I should read this. I'm getting really confused. Work with your team to find the sale price of the bed in two, oh, that's the part I skipped, in two different ways. Okay, so one way was here. One way is here, right? If you take 255 minus 147, you're going to get the sale price, which is the $98. And yet another way would be to use our multipliers, right? So if you want to find 40% of 245, that would be the sale price, right? Then you'd use 0.4 as your multiplier, and you take 0.4 times 245, and let's just verify that that's what we get for our answer. 245, move that up a little bit, times 0.4 is indeed $98. The second way that we could do this using a multiplier would be to actually find the amount of the discount and then subtract that from the original amount. And there, we're getting the exact same thing. So I actually did it in multiple ways. We did it with the diagram, we did it using some mental math, and we did it using our multipliers. 3 different ways to get the same answer each and every time. 40% is what you're paying, that's $98. 60% is the discount, that's $147. Depending on what piece of information you're asking for, you can either use this multiplier for the sale price or that multiplier to find out the amount of the discount. All right, taking a look at a different situation. Hugo's older sister, Sandra, had the same summer job for the past 2 years. Last year, she worked the entire summer and was paid a salary of $3,000. This summer, she's going to get a 6% raise. Hooray for Sandra. All right, so to figure out how much she will make, Sandra drew the following diagram. All right, so notice the difference between this problem and the previous situation. In the previous situation, you had your 100% here that when you added the discount and the sale price, both added up to 100%. So if you wanted to find the sale price, you would subtract the discount from the total. If you wanted to find the discount, you'd subtract the sale price from the total. In this situation, you got your 100% of your salary from the previous year plus an additional amount. So this is not a subtraction process. This is going to involve taking the original amount and adding on the 6% raise. Okay. So since Sandra's salary is increasing, does it make sense that her scale factor or the multiplier that we're going to use to find the new salary should be less than, equal to, or more than 1? Well, let's just think about this for a second. Hold on for a second. Okay, just had to take care of something. So she's going to continue making 100% of her previous salary, and that's equivalent to number 1, right? Plus, she's going to make an additional 6%, which is 0.06. So doesn't it seem like her multiplier should be 1.06? So I would say the answer to this question is it should be more than 1 because we're going to make her salary larger. Okay, so let's figure this out. What was her original 100%? Was $3,000. What is the amount of her increase? Well, what is 6% of 3,000? It's 180. So if you want to find how much her increase is going to be, we would use the 6% or 0.06 as our multiplier. But what if you just wanted to go straight to find the new salary? What number could she multiply by to get the new salary? And you see it right here, it is the 1.06. Okay, so if we showed 2 different ways that we can get to the salary, one way would be to find the amount of the increase, and then add it to the original amount. The second way would be to find the if we want to find the new amount, is let's just do it in one step instead. Let's just use the 1.06 as our multiplier, and that gives us the new amount. Okay, so you've got two options here. You can do what we did here and then add it in, or understanding that the original salary represented 100% whole salary plus the additional 6% gives you a multiplier of 1.06 that we used here. All right, let's take a look at this one. Marana teaches gymnastics lessons at summer camp. She is paid $12.50 per hour. If Marana were offered a raise of 100% per hour, what would her new hourly salary be? What percent of her original pay would be paid? All right, so let's think about this. She is not getting a pay reduction, right? She's going to make 100% of her salary. So 100% of 1250 is 1250, right? Well, she's getting a raise. Is 100% raise, which means we're essentially going to double her salary, right? It's going to go from $12.50 up to $25. So what is our multiplier here? It's got to be 100% plus an additional 100%, means the multiplier should be the number 2. So her new salary would be $25 per hour, and this is a 200%, or this is 200% of the original, right? 100% plus 100% gives you 200%, and our multiplier, you multiply 1250 times 2, you're going to get $25. Marana is offered a raise of 75% of her hourly rate to teach a private lesson. How much per hour would she be paid for the private lesson? Okay, so I want you to see if you can figure this out now. So if she's getting a raise, it's not being reduced, it's being increased. So she's going to make 100% of her original plus the additional 75%. And I'm pretty sure we're talking about this salary rate here, not this one. This one was if Marana were offered a raise of 100%. We're not saying she was offered that raise. This is what she makes right now, so use this as your base. Increase that by 75%. What percent of her original pay would she get? Okay. How much per hour would she be paid? See if you can figure that out. All right, let's see how you, what I do there. Actually, hit the button again. Let's get that out of there. All right, so first off, if you want to figure out the amount of the raise, we have to figure out what 75% of $12.50 is. So I'm going to use 0.75 as my multiplier. And take $12.50 and multiply that times 0.75. That gives me 9.375, which I think we should round that up to $9. And I've already forgotten it, 38 cents. So that's an 8 there. Stop it. Sloppy, sloppy, sloppy. Can have that. Great. So if I want to find out the amount of the raise, that's the ideal multiplier. Now, I can figure out what the new amount is by adding that to the original because it is a raise, so she's going to make her $12.50 plus the additional 75% to give us, what is that, 88 cents? What is that, $21.88. But if I wanted to do it in only one step, let's go ahead and multiply $12.50, $12.50 times 100% of her original salary plus the additional 75%, give us the multiplier of 1.75, and you get 21.875, which would round up to 21.88. So, to answer this question, how much per hour would she be paid for the private lesson, which it would increase to $21.88, and what percent of her original pay would she get? That is 175%, right? And that's why we've got this as our multiplier. What is the relationship between the percent raise that Marana gets and her new pay as a percent of her original pay? How is this related to scale factor or the multiplier between her original pay and the new pay? Well, her new pay is 100%, right? Her original pay plus the additional 75%. So that would be 175%, which gives you this multiplier here, which we used right there to get the amount of her new pay. All right, this is a stoplight problem, which suggests that there's an issue somewhere. Liam, was working on a problem and drew a diagram like the one below. Okay, he wrote this as his equation: $72 times 14 hundredths equals X. Does this agree with the diagram? All right, so here's the diagram. This represents 100% of $72. There's your $72 that corresponds to the 100%. Here, 14% correlates to this quantity up here. So if I multiply $72 times 14%, I should get this amount right here. X is not equal to 14%. This is 86%. So no, I do not like this. When you multiply 1400 times 72, you are not getting X, you're getting some other amount. So I think this is an easy fix. If we just change that, instead of saying times 0.14 and replace it with multiplier for this, then we would get X. Or another way to change it would be to call this Y, and then we'll replace the X with Y, and then I would agree with it. So that would be two ways that you could fix that, but I think we probably are going to go like this. So 86% of 72 has a multiplier of 0.86. So when you multiply that times 72, you get $61.92. So this quantity here should be $61.92. And the rest of it is going to add up to 72. So I believe that's going to be $10.08 would be the other quantity, because these two combined make 72. Now, of course, I'm curious. What is 14%? 0.14 times 72? $10.08. There you go. Okay, so we got that down. And now for some additional challenge. Wow, this is a fast one, isn't it? We're going to get this done in less than 20 minutes, I think. Well, I guess we had to pause and work a little bit. So, all right, so Ramon went to the corner store and bought more notebook paper to do his homework. The cost for the paper was $7.50. Let's go ahead and write down $7.50. But he had to pay a sales tax, which was 8.1%. How much will the notebook cost Ramon, or the paper? How much will it cost him? Remember, you've got to pay 100% of the price plus an additional 8.1%. Put it all together and use that as your multiplier to figure out how much he will pay for the notebook paper. Then, second part, if Ramon gives the clerk $10, how much change would he receive? This kind of a problem is the type of problem that you see on these performance tasks that we have in the end of year state testing, where we're going to synthesize a bunch of different skills that we've learned so far in 7th grade. And each individual step isn't too much trouble, but you don't have one individual step to do. You've actually got a few different steps that you got to put together, and you got to put together them in order to show that you are proficient with solving problems like this. Okay, so take a little time. Go ahead and build your multiplier based on what we've learned here. 100% of the price plus an additional 8.1%. Convert that to a decimal number, multiply it, find out what it's going to cost, and then take that cost and find out what your change is for a $10 bill. All righty. Are you ready? Pause. You need a little more time. Pause it. You should be pausing right now so you can work through this process. Or if you're waiting for me to stop yelling at you to pause, I will begin. So, you know what you should be doing if you didn't work through this. Let me start here. Oh, no, I better start here. 8.1%. If we put that into decimal form, we will move the decimal 2 places left. It becomes 81 thousandths, okay, or 0.081. Now, the original cost was 100%, $7.50, plus the additional 8.1% for the sales tax means our multiplier is going to be the decimal version of 108.1%. So let's take 1 and add this decimal number to it to give us 1.081. So when you take your calculator and you multiply the price of the notebook paper times our multiplier, we should get the new price that rounds up to $8.11. Wonderful. That's the new price. That includes sales tax. Now, you hand them a $10 bill. How much money are you getting back? Well, this is just a simple subtraction. There's no trick to that. Just take $8.11, subtract it from 10, you get your change of $1.89. Okay? So, all of these situations had something in common. You knew what the total price was, and they gave you a percent. And so, in situations, you are trying to find the part. You already had the total, and you already had the percent. So whenever you have situations like this where you're finding the percent of a number, you will always be trying to find the part. And so whenever you're trying to find the part, you can always do it this way instead, by finding a multiplier and multiplying this number times the total to give you the part. Okay? Okay. So we'll continue working further with these processes. Whole percent proportion works wonderfully. I highly recommend people use this on a regular basis, but in some situations, when you're finding the percent of a number, you can just use the multiplier and just get to our answer this way without having to go through the proportional reasoning. And I believe that is where we end today. Very good. How much time did that take? A little bit more than 20 minutes? Not too bad. All right, let's move on. Take care. Bye. Bye.
Hey, feeling good, like I should.